I've been using my Raspberry Pi based Kubernetes homelab for almost a year now, and I haven't really had any major issues. I've also deployed many applications that I use on a day-to-day basis. For example, for managing my files, and also an internal application called as Pay Your Bills to manage my financials. Now that I'm using it more often, I want more compute and also want to improve the way that the Kubernetes cluster that I've originally created can be scaled out to more Raspberry Pi based nodes. In this video, I'm going to talk about how I scaled it to now two Raspberry Pi nodes. One is Raspberry Pi 4 and now the newer one is Raspberry Pi 5. I'll show you what it is that I'm using to set up Kubernetes and also how you can do the same. Let's get started. So I'm using K3s to run my Kubernetes cluster. As you can see, it's built for lightweight compute devices, so it's a great candidate to get it up and running on something like a Raspberry Pi. It also has air-gapped installation, so if you don't have internet access, those sorts of features are also available. Also, the fact that it can be installed with just a single command is also something that drew me to using K3s in the first place. Let's talk a little bit about the architecture of the home lab that I'm currently using. When I originally started with the home lab, I only had one node, which was a Raspberry Pi 4. So that represents this left part of the architecture. In terms of nomenclature, K3s describes a server and an agent. So a server is more of a control plane node, and it houses the API server and the scheduler itself, as well as a etcd data store, which it uses SQLite by default to store its data. So that's what I originally started with. Obviously, in a production environment, it's not advisable to use the control plane to house your compute for your applications as well. So it's a good idea to separate your applications versus applications that are specifically designed for the control plane. So you, as a user of the cluster, deploy your applications on the data plane, and it is being scheduled and managed by the control plane. So that's how it works. In terms of the containers themselves, I have more experience working with Docker. So I used Docker instead of Containerd to run those containers. But obviously it's a choice of whatever it is that your team uses. As and when you want to scale your Kubernetes cluster now, so for example, if I want more compute, I could add more K3s agents, which could obviously vary in terms of their sizes or the features that they have. For example, I could use one of my full-blown tower PCs, which has a GPU as well, as a K3s agent to now have more compute and do various other sorts of things that a normal Raspberry Pi based agent wouldn't be able to do. If you want to set up K3s for a more real world and production scenario, you'd have to make sure you set up a highly available K3s cluster like this. And you should probably have more than one of your K3s control plane nodes, so that even if one of them goes down, a load balancer on top of it would route traffic to the right K3s available server. Obviously, this is not one of my requirements, so I'm fine with just one K3s server and one K3s agent. And now let's take a look at the cluster itself. I'm using K9s, but obviously you have the freedom to use whatever tool that you're familiar with. Let's take a look at the nodes first. So as you can see, there are two nodes. One is the Raspberry Pi, the original one, which has the control plane and master role. And most of the compute is still running on the Raspberry Pi 4. This is the newer node. Both of them are running the same Kubernetes version. And it's really easy to update the Kubernetes version for K3s, because you can just rerun the command updating the version and it will stop all the Docker containers, update the systemd service, and then restart the node. So that's pretty easy to do. In terms of compute, if you look at everything is pretty much running on the old Pi. A couple of services running here, but I'm exploring running SLMs or small language models on the Raspberry Pi 5. So I want to keep this relatively less occupied. In terms of access, as I said before, I access the Pi, the older Pi, directly through its Ingress, and I'm using an Ingress Nginx as my Ingress controller. So as soon as I'm connected to my VPN, I can go into this website, which then resolves to the DNS name provided by the VPN that I'm using. So this is only available when I'm connected to the VPN. As I mentioned, K3s provides really easy way to install things. So the way to install the server itself is through this command. So you set up your cluster using a single command. To register your agent node onto your server, first you have to receive your password from the server node. So on the left hand side, this is my server node, and this is where the password lies in this file. So you can copy that value, and then on your agent node, all you have to do is again just install the agent, specify if you want to use Docker or Containerd, paste in your node password here, and then this has to be directly accessible to the server. So that's what this IP is. This is my internal network, so I can directly access without having to go through the VPN. Once this finishes, it's going to register, and then this node is going to show up in your kubectl get nodes command. Both the server and the agent run as systemd services, so they're really easy to manage if you're familiar with the commands like generalctl, seeing how those logs show up if there are any errors. And if you want to just restart the cluster, you can just do sudo systemctl restart, and it'll restart the service. So that's really easy to manage. That's all I wanted to cover in this video, to give you an update about where the homelab project is heading. And there's obviously the parallel sibling project of PO builds continuing to being developed. So feel free to check that project out on my GitHub as well. If you have any questions about how you want to set up your homelab, or expose it via a VPN of your choice, maybe expose it as a public service, as a SaaS offering, those sorts of scenarios can also be discussed. So just add them in the comments and we can discuss them in further videos. See you in the next one.